Hello, this is Paul from Foresight Tech. In this lecture, we're going to prove inequalities using integral property. I'm going to show 3 more properties here and 2 examples. So the first property is this. If f is a function is non-negative greater than or equal to 0 for the domain x between a and b, a function greater than 0, then the integral or the area under the curve is non-negative. That's definitely right. So I show example like this. And if this is a non-negative function, y equals fx greater than or equal to 0, of course, definitely this is a to b. See, where is the integral? So this area is integral because everything is above x-axis, so definitely is positive, right? Okay, so the second, if we have 2 functions, f is greater than g, the integral of f, of course, is greater than the integral of g, right? Y, or probably I can show this graph here. Okay, like if I use this, if I say f is greater, if f is here, or y equals fx is higher than b. Okay, I say this is a, this is a b, and higher than, if this, of course, don't need to necessarily be parallel. This is y equals gx. Definitely f is higher than g, right? So what is the area for g? See, this is the integral for gx. Okay, so what is the integral for f? This big one. It's easy to see the big one is greater than the small one, right? The big one is greater than the small one. Okay, so one more. Look at this property. We're talking about the one function. If f has the minimum value lowercase m, has the maximum value uppercase m, and then the functions, okay, the integrals of this function can be bound. This we call it the lower bound. This is the upper bound. Okay, so be bound. This we simply say the lower bound, and this we call it the upper bound. The upper bound, right? So why we have this? I also later I will going to show a graph. Okay, so here, but first I will going to give exact proof for the question number 3. Okay, for 3 I show a proof here first. Why this? So we're going to 2 steps. The first, this function has the lower bound is this y, because we can use, okay, f is greater than m, right? So we can use the second property. We use the second property to get the left inequality. Also, I use the second property to get the right part of the inequality. So what is the left? So I'm going to do this. So like a to b fx, right? And the dx should be greater than or equal to greater than g. This time g is m, right? So this is greater than m, so we can have this. We can have lowercase m put here, right? So this the first is property 2. Okay, this is property 2. So property 2. So we can find this definitely, and then of course you know how to do calculation. So this is a constant function. The area is a rectangle. So that means the second to calculation, this is a rectangle. We use the area. The area is the height is m, right? Times the width is b minus a. See, we proved the first half, and then we're going to prove the second right. Okay, the right second half, which is this. So a b f x dx. Because this function is bounded by capital M, so less than or equal to this. Capital M we put here. Now you know this is also property 2, right? This is also property 2. And then the second, you know, this is a rectangle, right? So the height is a capital M, this is a rectangle. Okay, so the rectangle. So to calculation, what do we have? The height times the width. See, this is bounded by this, so this is the right half. Okay, so in this way we prove the property of 3 is correct. I said another, I was going to draw this graph to understand this also. So I was going to draw I'll draw a little bit bigger graph here. Okay. This graph is going to show the third one. If I say A is here and B is here, the function f, if suppose I say is this is the left, this is the right, this is y equals fx. So what is the integral? So everyone knows the integral should be here, right? This is the integral. That means, so I find the integral. This is integral a to b f x dx. Okay, good. And then we're going to find what is the left side. M is the minimum. So if the minimum, I put it here. Okay, so this is the minimum, right? Okay, so the minimum. So I draw horizontal line. Let me see. If I draw a little bit solid, little bit solid, and then what do we get? Okay, we get a rectangle. So if I highlighted the rectangle is like this. See? Highlight it one more time. Okay, what is the area for this? What is the area? We know this is m lowercase m times ba, lowercase m times b minus a. See, look at the integral under the curve, definitely greater than this, right? That means the left. What is the right? Capital M is the maximum. So I put the maximum here. So I say, okay. So if this point is the maximum, so this time what is another? This number is also the area of a rectangle. This is the rectangle. You can see. Okay, if I draw a little bit like a hole. Okay, so put from the bottom to the top. So now I will not highlight. Okay, the big one, like a square one, is the right side. If I'm going to get this word, this is the height m times the width b minus a. Can we see? This is the biggest. This is a middle. This is the small one. That's exactly this, right? Also, you can prove in this way. Now, I'm going to use this to 2 examples. This is the first example. So we're going to see, and use the property we just see. We have 3 properties, right? To verify this one, this is a non-negative. So let's go back. Non-negative is the first, right? The first, what we need to do if the function f is non-negative, then the integral is non-negative. Is this true? All we need to do is look at it, check. Don't need. Okay, so this question without evaluating the integral. Okay, so don't evaluate it. We're just going to do another way with the property to compare. So this is what if I say this is fx. Okay, now the questions, is this fx greater than or equal 0? If this is true, then use the first property. This is true, right? So all we need to do is do this. This is true. Why? Because we do this. Because we do this, fx is equals x squared minus 4x plus 4. See, this is a perfect square. Okay, we say this is perfect square. X minus 2 square. Okay, if someone forget it, this is a negative b squared. This is a b over 2 half of b squared. Right, definitely this is a perfect square. Now let's say we use a perfect square. We use the perfect square formula. We will have this, okay, and then this is a null, right? So this is greater than or equal to 0. See, that's true. That means this is true. If this is true, now we can get a solution. Okay, so we have this, and the integral 0 to 4 fx dx greater than equal to 0, right? That's the property. So remember the property. The the second property. I think we just get. So where? Oh no, the first property. Sorry, the first property. Non-negative integral function. The integral is non-negative too. So the first property, right? Get the first. One more example here. And look at. So it's the same, okay? So we're going to prove this inequality, but we have two parts. So with two parts, remember, and the property we have one. See, and the last property, okay, the property 3. So we also have a have two parts, right? See, it's exactly the same now. So the function is what? We use the property 3. So we need to do is to bound the function, right? All we need to do what the integral function. This is fx. What do we need to do? Find remember, we need to find out what is m, what is capital M, the minimum, the maximum, the minimum and the maximum. How to find the minimum and the maximum? Okay, so I will draw graph for you. So this is a sine function, so it's easy to look at. If I draw, this is a sine function. Remember this, right? Like this. Okay, I stop at here. This is one period. This is 0. This is pi. This is 2 pi. And this is goes to 1, right? So this is goes to -1. And we look at a and b. So this time the integral. This is a, this is b. Where is a? So we need to do this. Pi over 6 is 30 degrees. Pi over 6 is like here. Okay. This is a pi over 6. Pi over 3, 60 degrees like this. Pi over 3. Both number is less than, this is a pi over 2. Okay, remember this. Pi over 2. So the function is from this point goes up to this point. Can we see? Okay, so this time. Okay, and the function is this. Y equals sine x. X is between this number and this number. So this is what? This is the increasing function. So increasing function. If it's increasing, that's easy, okay? That's easy to find out. What is m? What is lowercase? So this is the lowercase m, and this is the capital M. So what are we going to do this time? I'll just put here. So the lowercase m, everyone know, is the left-hand point. The left, it means the function f at pi over 6, okay? And is sine at pi over 6. You know this is 1/2. Okay, what is a capital M? Is the function f at pi over 3, the right, which is sine at pi over 3. To calculation, you remember this, right? Special value. And then now we can directly use the property of 3. The third property, right? So I just do this. Remember this function from pi over 6, to pi over 3. This is f for x, and the dx should be bound. The upper bound is m times b minus a. Okay, the lower bound is this lowercase times b minus a. Okay, of course, what is b? So this is b. What is a? This is a. What is m? Both we know, right? Okay, so we just plug in. So we're going to do the calculation for the left. So the left, look at this. The left is what? Is 1/2. Okay, so I plug 1/2 times pi over 6 minus pi over 3, and do calculation. Do calculation. What do we get? I think I get it wrong, right? So b is pi over 3. So sorry. This is pi over 3. This is pi over 6. Okay. And then do calculation, what we get is a pi over 12. Yeah, that's good. This is the left. Definitely we'll find this. The left. Now we're going to find the right. The right is this. We do calculation. This is square root of 3 over 2, right? B is pi over 3 minus pi over 6. Okay. Do calculation. definitely we will find is square root of 3 times pi over 12. Okay, so this is the upper bound, and the upper bound is there. Yeah, so that's all. Thank you.